Okay, ladies and gentlemen, it is Gene from the Mavstar Observatory. It's the 17th of July. As you know, on the 17th we pull the SD card out the TriMag and out the magnetosphere sensor. We put that data up onto the website. It's already there if you want to quickly go over there and have a look, but we'll be talking about it a bit later on in this video anyhow. We also pinpoint the magnetic North Pole on Google Maps and give you the coordinates of that. If you're, like myself here and a few others that follow us, you can pin it on your own Google map and just track the progression of the magnetic North Pole, which is at the moment still heading towards Russia Central. Okay, so before we get into it all, guys, big thanks for those of you that are supporting us. I'll tell you now, on your two hands you can count the people that support this observatory. I know times are hard, guys, but we're dealing with one of the biggest anomalies mankind has ever seen. Just let that sink in for just a few seconds. The biggest anomaly mankind has ever witnessed and never documented. And when I say documented, he wasn't around during the last magnetic reversal, even the excursion 12,000 years ago, which wasn't a completed reversal, to document it in the same manner as what we are right now. We track the magnetic North Pole every 3 seconds, 24 hours a day, 7 days a week, 365 days a year. That equipment never stops taking a reading. The only time it stops is when we pull out the SD card for a short space of time, chuck it into the computer, take the data off it, format the SD card, put it back in there, reset it, and that's it. It's off for the next month. So guys, let's get into it. So it's about 6:15 here in the morning. We've already been at it about an hour and a half processing the data off the SD cards, which is already up on the net, as I mentioned earlier. If you're tracking the magnetic North Pole and you want the longitude and latitude, I'll just very quickly read those out for you. You can see them there in the box yourself. 83 degrees by 37 hours, 36 minutes, 45 seconds north. The longitude is 125 degrees by 49 hours, 52 minutes and 3 seconds east. That's the coordinates for the magnetic pole as of today, the 17th of July 2020. Now I'm just going to pull out the map. We're going to pull out the map so we can see how close we are to that 40-degree mark, and then I'll zoom out a little bit more so you can see the corridor of where the magnetic North Pole has been tracking now for over the last 100 years. If you've been following us, you know that recently, over the last 30 years, it has covered more distance than it ever has done in a short space of time. So let's go and have a look at that. So okay, now we've locked in the position and the date. I forgot to mention, but I will mention now, it's done another 3.7 miles in the last month. We'll just zoom out now so we can see where that is in comparison to the 40-degree mark. Here we go, we're coming up on the corridor of where it's been tracking. We can see the 40-degree mark coming in there now. And if we just continue to zoom out, but before we do, just take a look, guys. You can see how close we are now, coming up on that 40-degree mark. If we compare that with 2016, we was relatively quite a distance away, but now 2020 we're on top almost of that 40-degree mark, probably a couple of years away if that at the max. Carry on zooming out, we can see the corridor there and we know where this is tracking. We've got a pin mark in somewhere central Russia, so this is where we're going. This is where the magnetic pole is, and we know that because when we look at the magnetic intensity map we can see that that is the epicenter, and we know by studying poles now that where the epicenter of the strongest intensity is usually is where the dipole is, or the magnetic North Pole. The only reason why we're looking at a different story over the northern hemisphere is because in Canada there is, where it used to be the magnetic North Pole during the 1900s, there was a strong epicenter of magnetism over Canada. That epicenter has weakened over the last 120 years or so, and and what's happened over Russia is a new magnetic anomaly has formed. The intensity has begun to increase in strength, and therefore it is pulling that magnetic pole that makes our compass point to it. It's pulling that towards the epicenter in Russia. Let me pull up the map so we can have quick look at that, and I've also got a quick video which I want to show you, which shows you the depletion of that epicenter over Canada weakening, and the one over Russia central increasing. So first of all, we'll have a quick look at the map. Just bear with me. So here we are looking at the main field total intensity map, and you can see these epicenters that we've been talking about. Is the one over Russia. That's where the magnetic North Pole is heading towards. At the moment, the magnetic North Pole is somewhere here in the Arctic Sea. Then we've got the epicenter, which is weakening from Canada. This is where the magnetic North Pole was for thousands of years. Only 120 years ago, it started to migrate because the intensity began to weaken, and at the same time, Russia's intensity started to increase in strength. What's happened is when you get two magnets and you put the compass needle, as I've shown in those little experiments that I've done, what happens is the magnetic North Pole of the compass points in between the two. Now, if we move if we use an analogy of moving the Russian magnet closer to the compass, what will happen is it will demonstrate, a strengthening of the field, which is attracting the needle of the compass. And when it does that, the needle will move closer to one in Russia and further away from the one in Canada. And we could do the experiment the other way around. We could put the magnets at the same place and the compass in the middle of the two. It would be pointing in the centre. But if we just pulled the magnet from Canada further away, it would slowly drift again over towards the magnet that we would class as Russia. That's exactly what's going on. But if you look at the bottom right hand corner of this total intensity map, you'll see the epicenter. There is a South Pole in the slap bang center of it. That's how we know where the pole is tracking now, because poles are in the epicenter of the total main field strength. The reason why it's not at the moment in the northern hemisphere is because we've got two high intensity regions. I know that Canada is weakening. You can see that on these like isobars, or these bars that measure the strength. The darker red they are, the more stronger the intensity is. But we don't have something on the southern hemisphere like we do over on the northern hemisphere fighting for that pole. It's on its own. The only other thing we have in the southern hemisphere is the mid-Atlantic anomaly, and that is the weakest region on our planet. And I've been saying, guys, I've got to get hold of this couple today and just ask them if we can get, because I've got a family member who's got family living in Brazil at the moment. I'm going to ask them if they would, inquire back home and see if we can get this muon detector out there, as well as the magnetometer, and we can monitor that. If we get that in Brazil, not only do we score big points for ourselves because we're in the weakest region of the earth, we can measure how much weaker it gets over time, but we can also monitor the influx of radiation with regards to muons and those upper atmospheric collisions. Now that completes our set. We've got one in the highest region just creeping up over Perth, Australia right now with our muon detector. We'll be having data coming shortly from there, and not only magnetometer data but muon data. But we'll also, if we get one in Brazil, have one in the weakest region on our planet. That's a set, guys, and that gives us a lot of information, not just on the intensity but the levels of radiation in the strongest and the weakest regions in the earth. Can I just ask you guys, is there another channel on YouTube quite like this one? A lot of people talking about the magnetic pole reversal, a lot of people talking about grand solar minimum, and a lot of people talking about cosmic radiation, but have they got the equipment to monitor it? Are they tracking the magnetic North Pole like we are now at this observatory? We've got equipment in Arizona, Canada should be arriving shortly. We've got equipment in Hong Kong and on the east and west coast of Australia, and here in the UK, slap bang in the centre on this chart here that we're looking at. We've got the TriMag system monitoring every 3 seconds that position of the magnetic North Pole, and we have the magnetosphere sensor detecting the strength of the field around the UK right now. is there another channel on YouTube quite like ours? You know, here's something, I'm going to blow my own trumpet, guys. You know, I don't care what people say. Why not? If you're doing something good, I think it's well worth telling other people about it. You know, we have came out before NASA and told people, the public, as many as we could reach, that there was a magnetic anomaly taking place on around about January this year. We was the first to come out and tell them. A couple of weeks later, NOAA and these other organisations announced that they, because of the change in the magnetic field, they would have to update the World Magnetic Model. And this was the map that they produced. When they produced it, they had a problem with the date on the bottom of the map. And we told our subscribers about that. And one of our subscribers went to that department and told them that there was a problem with the legend on the chart. And they changed it immediately. Can you believe it? That our tiny little observatory dictates to these big companies and organisations that they are making mistakes, and on that information they correct it. I just want to ask one more time, is there another YouTube channel on YouTube quite like ours doing what we're doing? We're providing a service here, guys, and you know, we ask just for a simple thing, a bit of financial support to keep us going. And I've said this many times, you know, there is worse things you can do than fund an observatory that is studying one of the rarest anomalies that takes place, you know, on this earth. And the reason why you should be supporting it is because if we just look at our neighbouring planet and just bear in mind what happened to that planet, it is not something that cannot happen to our planet equally as what happened to Mars. It lost its magnetosphere, it lost its atmosphere, it lost its water on its surface. It's no longer got a magnetosphere. There is no volcanic activity. You know, we've pointed out in the last 2 years, guys, that there has been a reduction by 1/3 of the active erupting volcanoes on this planet. People should pay attention to this. Our world is changing, and changing fast. You know, I know these, you know, when we're talking a couple of years, and that seems like a long time, but really in comparison it's about 700 days, isn't it, or thereabouts. You know, for 1/3 of the volcanic erupting volcanoes to disappear or go dormant for a bit, that's big news. You know, for a planet that is going through a magnetic reversal, that is really big news, guys. That's why we are dedicated to doing what we do on this channel. I just want to put it in perspective. I want to run a quick video animation of how fast things are depleting over in Canada and how fast things are increasing with those intensities, and you'll see the pole in, you know, the time frame of this video moving across there. Have a look at this. So this is on repeat, so it's just, or loop should I say, it's just going to keep going over and over. It starts off around about 2000, gets to about 2016, then goes back again, so it's about 4 years out. But nevertheless, just check out the first top left hand disc. You'll see in real time over that time period how much that magnetic north pole's moving. Now for those people out there on other channels talking about, you know, it's going to be 1,000 years before it moves 200 miles, go and dream on. It's going to be nothing like 1,000 years. You know, you can see it move in real time. You can see the intensity over Canada on that disc weakening as that pole goes closer and closer. As I said, it was tracking towards Russia, that high intensity. The reason why it's moving is because, you know, over Canada the intensity is reducing, and therefore the fight for the magnetic north pole is definitely on, and you can see who is going to win at the end of the day. So we know what's going on now. We know what's created this problem in the first place for the magnetic poles to start migrating, and that's a milestone, guys. We know exactly where it's going, and when it gets there, what we've got to bear in mind, because we can see the intensity, if we look at the center disk at the bottom, we can see the intensity increasing over Russia, and we can also see the south and north intensities over the northern and southern hemispheres merging closer together. You know, poles attract each other, so a north and a south, the opposites will attract each other. Maybe when that pole gets into its epicenter, or before it does, it will probably catch up somewhere towards the equatorial region, and we could see a magnetic connection there with the north and south pole. And what happens when you bring two magnets together? They form one magnet. So at that point, the Earth may well go into a reversal. But what we're expecting to happen before this is a little trick up the magnetic migrations sleeve, so to speak. I'm talking about that 40-degree mark, because we know when it gets into that 40-degree region that there is a difference in the strength of the field lines. It goes from the strong field lines, which keeps that magnetic north pole at the moment tracking relatively slow, and then when it passes that point, it goes into the weak field lines. At that point, it is like a turbo kicks in, and that needle should flip, and we should get a magnetic reversal at that point. That is all according to the experiments that I've done and I've showed you guys in other videos. They're there. I know you've got to go way back to get into it and have a look, but they are there on there, and you'll see exactly what it is we're talking about with these poles and the way in which they reverse after they go into the weak field lines. But guys, it is nothing small what is taking place on our Earth with the pole reversal. It is affecting the amount of cosmic radiation as the magnetosphere weakens, therefore, clogging up in our jet streams. We're having these super jet streams as opposed to a nice wavy line around 30 degrees and 60 degrees north, with the polar and subtropical jet streams over the northern hemisphere and southern hemisphere. As you can see on the top right hand screen, the disc, you can see that it is leaving the Antarctic Peninsula, the pole, and moving towards Australia, and moving towards Australia at the same point in time where we've got two magnetometers on the east and west coast monitoring that position of that pole, and also now a muon detector. So as that strength of that big intensity down there in the south creeps up over Australia, we're going to see just how much protection is increased during that point in time. As it creeps up over the continent of Australia, we will see how many muons come through the atmosphere or how many don't. And equally, when we get into Brazil, because you can see the South Atlantic region, that dark blue region on that lower disc, increasing in strength. Well, sorry, I know it looks a little bit odd when I say it's increasing, actually decreasing in magnetic intensity. That is the lowest region on our planet, but the size of that lowest magnetic intensity is increasing, as you can see on the time frame of this video, and doing so quite fast if you ask me. I know 20 years is not a long time, but look at how much the magnetic intensities around our world are changing in the time frame of this video. Okay, so before we end the video, we're going to go over to poleshiftnews.com. If you haven't been over there, go and check it out, because there's a lot of stuff on it. It's not just dedicated to the magnetic pole reversal. There's a lot of data on there. There's stuff in the Learning Centre, videos that you can watch, all on this topic. But go over there and have a look. If you want to see where the earthquakes are happening, you can type in the magnitude you want, and it will go and find all that data for you. You can have a look at the latest on the erupting volcanoes, Schumann resonance, data from other magnetometers, other observatories, including ours, and you can see where the information is coming from with regards to our magnetometers that are currently out there. Now, I've got to add the one for Canada as soon as that comes online, but we're just waiting at the moment for it to get delivered there. We've got a feeling, me and Kendall, that it's been held up in customs in Canada at the moment, but it should be released at some point and make its way to Kendall, and then at that point we could do a 24-hour test, 7-day test, and then we'll set it up for the month, and it's off like the rest, recording the data, and then it just comes back here like it normally does, gets processed at that 1 day a month period, and we put it up on the website for you guys to see. Okay, so let's go and have a look over Pole Shift News. So just very quickly explain what's going on with this chart. If the numbers keep going up, or the bar, the light blue line in the centre of the chart keeps going up, we know it's tracking towards Russia. If the numbers went down, it was going back towards Canada, the magnetic North Pole would. But if you go back in the history of all our data collected charts like this, you would see it gradually going up and up and up. Now, when I look at the heading on the TriMag system, we're at the moment 1291, and the more frequently that number comes up is an indication that it is still tracking towards Russia, without a doubt. Now, the other thing is that, you know, it is about to creep over to the 13, which means, again, you know, it is still heading towards Russia. And, you know, it's just amazing how accurate and simple, really, that this equipment works. I mean, we've got 3 magnetometers in the TriMag system, and they all have a XYZ axis of tracking ability of the magnetic North Pole. So, you know, in total, there's probably, I don't know, 500,000 readings every month, just on, you know, the date, the time, the heading, and, you know, that is a share of 3 magnetometers. Our master, which captures it randomly off all 3 magnetometers, and then compiles that on the SD card for us to collect it. But yeah, you know, we're still tracking, guys. Without a doubt, doesn't matter what anyone else says on YouTube or from these organisations, we are still tracking at just this month, just under 4 miles, but on average 4 miles every month, or every 4 weeks, or just over thereabouts. You know, 4 miles. Can you believe that? We're very close to that 40-degree mark. Let's have a look at the magnetosphere data. Because we're pushing on now over 20 minutes with this video, I don't want to waste too much of your time, but I do want to at the same time give you as much information about what is going on right now. And over at the magnetosphere data collection point, you can see that around about 3 weeks ago there was a little anomaly that took place here, where it dropped the magnetosphere strength. Not uncommon to see. If we have a look at other charts, we can see that it does do this, but it has remained from that point on relatively quiet with regards to activity. Yes, it's got its standard daily shift of about 2 microteslas, but that is perfectly normal. You know, what we are expecting to see over the next few years is a slow decaying of the microteslas, and numbers therefore dropping on the chart. As you can see, these anomalies do happen. Sometimes they're very short. That one looked like it lasted probably around a week, as it declined in field strength, went right down, and then remain at around 199 microteslas. Again, this is not telling us, these numbers not telling us that there is 199 microteslas of field strength, because there's not. There's about 57, if that, on average. The number is a benchmark only, and it just shows us a starting point. And if you go back over the lifespan of the magnetosphere sensor, you'll see that it's always hovered around 198, 199, or maybe go up to 100 200 at a given top point in time, you know. But there you go, you can see over the history of the course of the you know, collecting of the data, there was a lot going on in that month. This is from the 17th of the 6th 2019, so, you know, just 13 months ago, you know, the magnetosphere was over 200 microteslas and dropped down to 199, and then just went at the end of the month, you know, just slightly back up. But these charts are there for you to have a look at and come to your own conclusions on them. You know, what we do is collect the data, show you it, and, you know, allow you to make your own assumptions. That's what it's all about. Guys, I know the video's gone on for 20 minutes or a bit longer. I apologise for that. Like I say, there is a lot of data I want to get over to you and put it in a manner which you can understand it, so it's not all tech, you know, and going over your head and mind-boggling. I have to, guys, you know, being the person that's running this observatory, mention to you guys the importance of supporting it. You know, we are miles away from what our objection was to, you know, get some more equipment for this month. We're miles away from it. You know, the only way we are going to achieve that is if we put a goal in at the last minute. You know, one of those rare occasions where, you know, everything changes at the last minute, but we'll just have to wait and see. You know, if you want to support what we do here, there's a link down there. become one of our patrons. Or, if you just want to make a quick donation here and there, use the PayPal link. It's the best way to get the money to us. So, I'll leave it there, guys. You have an amazing day. Take care of your family. The world is changing all around us. And on the back of that, I'm just going to say one thing. As always, you take care. Bye for now.